Number 1, an athlete ran at a constant speed for 12 seconds. The part of the linear function shown represents the distance the athlete ran in yards as a function of the time in seconds, x. What is the domain of the function for this situation? So since we're looking for domain, we're looking for all the x values that represent my function. So I'm going to look from my far left to my far right. So when I look from my far left to my far right, I can see it begins at 0 and it ends at 12. So the domain that best represents this situation, oops, would be B. Okay, number 2, the graph of a linear function is shown on the grid. What value best represents the y-intercept of my graph? So my y-intercept, that means I need to be looking along my y-axis. And the value where the line crosses on my y-axis is my y-intercept, which would be 0 and -2. So my y-intercept is A. Number 3, the graph of a linear function g passes through the points -7, -4, and 7, 6. What are the slope and y-intercept of the graph? I'm going to go ahead and graph the points that they gave me. So -7 and -4. And then the other point was 7 and 6. And I'm going to use these points to calculate my slope. Now I could really use any points, but I'm going to use these points since these are the points that they gave me, just to be sure. So I'm going to find my rise and my run, or my change in y and my change in x. So I can see here I went from -4 all the way up to 6. So I increased by 10. And I went from -7 all the way to 7 on my yellow here. So I increased, or on my, from my x values for my change in x. So I increased by 14. And I can also count the dots, right? Count my scale here to see that I increased by 10 and I increased by 14. Just make sure you pay attention to what your x and y axis are counting by. So my slope is 10 over 14, which would also be 5 over 7. And then my y-intercept is right here on my y-axis. So again, we check along my y-axis here and look at where it's crossing, which is at 0 and 1. So my y-intercept is at 0, 1. So my best answer for this would be B. Okay, number 4, the graph of a linear function is shown on the grid. What is the rate of change of y with respect to x for this function? So my rate of change is the same as my slope. So I'm going to look between my 2 points. First, I can see it's negative because my line is decreasing. But I can see I have my change in y there and then my change in x. So I can see I went from 7 all the way down to 1. So it decreased by 6. And I was at -4 and I ended at 4. So it increased by 8. So -6 over 8 equals -3/4. So the best answer would be D. Okay, number 5, a part of a linear function is shown on the grid. What is the rate of change of the part of the linear function shown? Oh, I'm sorry, not what is the rate of change? What is the range of the part of the linear function shown? Ooh, that was confusing me for a second. Okay, so the range. So from my range, I'm looking from bottom to top. So I can see I'm starting down here at -4 and it's ending here at 2. So from -4 to 2 is what I'm looking at here. And I also have myself an open circle here, which means it's not equal to. So all my numbers are going to be greater than -4, but not equal to -4. So the range is the set of all real numbers that are greater than or equal to -4, not equal to, so not that one. We want greater than, and not -2, and not -2, okay? And then we also need them to be less than 2. So it's between -4 and 2. So we also need it to be less than 2. Okay, number 6, the altitude of an airplane is changing at a constant rate. The table shows the linear relationship between the altitude of the plane in feet and the time in minutes. Complete the statement. Complete the statement that describes the rate of change of the altitude of the airplane with respect to time. Okay, so remember we can choose any points to find my rate of change, just like slope. So I'm actually going to skip and go from 1.5 to 6. So I can see that I increased by 5.5 here. And then from 25,000 to 500, I decreased by 13,500. So now to find my rate of change, I'm going to do my change in y, 13,500, divided by my change in x, meaning it decreased by 13,500 feet in 5.5 minutes. Sorry, guys, let me edit that. 4.5. That is 4.5. I was a little distracted by my things happening in my house. So it increased by, it decreased by 13,500 feet in 4.5 minutes. And when I divide that, I get 3,000. So the altitude of the airplane decreases at a rate of 3,000 feet per minute. Number 7, the graph of a linear function f is shown. What is the zero of f, or the zero of the function? So my zero is just my x-intercept. So in this case, my zero is located at 2, 0. So my answer would be C. Number 8, the table of values shows a linear relationship between x and y. What is the slope of the line represented by the table of values? So finding my slope, I'm going to find my change in y. It's decreasing by 8. And from -7 to -2, it increased by 5. So -8 over 5. So A is my answer. Number 9, the water level in a tank is changing at a constant rate. The graph shows the relationship between time in hours and the water level in meters. Complete the statement that describes the rate of change of the water level with respect to time. So if I look here and I start at the beginning, I can see that at 0 minutes, or at 0 hours, we have 9 meters of water. And then the next time I can really see a clear point is right here. And at 4 hours, now I have 8 meters. So these are my hours, and this is how much water I have, my meters of water. So I can see it decreased by 1 meter in 4 hours. So decreased by 1 meter in 4 hours. So the water level decreases at a rate of 1 meter per 4 hours. So if it's -1 for 4, that means it's decreasing by 0.25 per hour. And number 10, a swimming pool can be rented for $110 per hour. The pool can be rented for either 1 or 2 hours. The cost in dollars to rent the pool is a function of the number of hours the pool is rented. What are the domain and range of the function for this situation? So the domain would be the number of hours. So that would be 1 or 2 hours. And so my hours in 1 hour and 2 hours. And in 1 hour, it would be $110. And for 2 hours, it would be $220. So that would be B. Number 11, the daily cost of hiring a plumber to work X hours on a repair project can be modeled using a linear function. The plumber charges a fixed cost of $80 plus an additional cost of $45 per hour. The plumber works a maximum of 8 hours per day. For 1 day of work, what is the range of the function for this situation? So I'm going to go ahead and just write an equation to represent our situation here. So I have y equals 80 plus 45x. So x represents my number of hours and y is the total cost. So the plumber works a maximum of 8 hours. So they can work 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, or 8 hours. So I'm going to kind of go ahead and start to plug that in. So if they work 1 hour, that means they're making 80 plus $45, which is $125. Oh, I'm sorry. Okay, that's for 1 hour, but actually they can work 0 hours. So we're going to have 80 plus 45 times 0. So the least amount of money we can make is $80 if they work 0 hours. So maybe the plumber just showed up and had a cost of $80, but they didn't have to do any work. And then the most they can work is that $80 plus 45 times 8 hours, which would be $440. So B is going to be my answer. Number 12, what is the slope of the line that passes through the points 26, 7 and negative 39 and 12? I'm just going to go ahead and place these in a table, but of course you could use your graph if you choose. So I can see that I increased by 5, so the change in my y is 5. And I decreased by 65. So I have 5 over negative 65, which is going to give me negative 1 over 13.